Hello and welcome to the TradeStation Masterclass. I tripped on my own tongue. So um, today we're going to do an easy language class and talk a little bit about loops and arrays. We are privileged to have John Brook with us today. So he's going to share some of his expertise in this area as well.
Hi there. Hi there.
Before we get started though, the usual introductions and disclosures. My name is Jesus Nava, Director of Client Training and Education for TradeStation Securities. John Brook is Director of Easylanguage Services for TradeStation Technologies, and we're both glad to be here to talk a little bit about this technology in TradeStation's programming language. Keep in mind that every symbol and idea that we talk about is going to be for educational purposes only. These are not recommendations of TradeStation. Be aware that active trading is not suitable for everyone. It should only be done with risk capital, and past historical performance, of course, is no guarantee of any future results. For additional information on these disclosures, please visit our website, www.tradestation.com/important-information. All right, guys, let's talk a little bit about loops and arrays. And John, thank you for joining us today.
Hey, Jesus, my pleasure. Glad to be here.
I don't think we can hear you, John.
Can you hear me? Can you hear me? Let me see. I've got
I see your microphone coming through, but I don't hear you. Can you guys hear me? By the way, I didn't check the sound, but I think my microphone is working. Can somebody let us know in the chat if you can hear me? Yes, can hear John. Oh, why is it that I can't hear him? Can you guys hear me? Okay, so you also hear me. So let's see if it's a matter of my computer speakers. Let's see. This is, oh, maybe it's not set to the right thing here. Okay. Now, John, can you hear me?
Test. Can you hear me?
Okay, that's not still coming through. Why is it? Should not be coming through. Give me just a moment. Yeah, I think they were switched somehow. Speakers. Why is it that I don't have access to my regular speakers? I go to the settings here and they're not available anymore. Let me log out and back in and see if that makes a difference. Hold on. Maybe now? John, can you hear me?
I can. Can you hear me?
Yes, I can hear you. I had to switch to my headset because somehow.
Oh, there you go.
Yeah, I just lost track of my computer is not showing, my computer speaker. So I probably need to restart. So rather than doing that, I said, let me just switch over to something different. Okay, let me go ahead and start this off again. All right, there we go. Okay, so let's start talking about loops and arrays. And, I didn't have much time to prepare for the content of this presentation, so I'm glad that I have John here with us. But let's go and talk about, from a very basic standpoint, what loops and array are used for, and if there's any other technology, because I think last time we spoke about this topic, I think we said that there's probably newer easy language code that could be used in replacement of loops and arrays. But the definition for a loop is right here in this PowerPoint. Before I continue, let me go ahead and make that PDF available to everyone here so that everyone has it. So give me just a moment while I pull up our media server, and I can get that PDF uploaded for everyone. It's been one of those crazy days that we have meeting back to back, and I just I'm honest with everyone here, didn't get my documents ready. Let's see. Okay, I'm going to be sharing that inside of the chat window. If you're going to be sending questions or comments about what we're going to talk about, feel free to do so in the chat. Just set your chat windows to everyone so that we all get your questions and we can all follow along. All right. Correct me if I'm wrong, John, but a loop or a for loop, which I found out that a for loop and a while loop are pretty much the same thing. You know, they allow you to go through a piece of code repetitively. So if you want to repeat the code,
That's right.
so many different number of times, you can create a for loop or a while loop.
Yeah, that's right.
Sorry?
The only difference is that the for loop has, as the condition of the for loop, it's going to iterate a specific number of times. Whereas as the condition for the while loop, it'll iterate until some condition is met. So it's a number of times versus meeting some condition. But you're exactly right, though. The purpose of both is to execute some code a number of times.
Yeah, and a lot of people, you know, a lot of times when you're faced with the decision of using a loop, is mostly when you know for sure that you're going to need it. So what I'm trying to say is that the loop that is available in Easylanguage is a great feature, but it's not something that a lot of people use. Only in certain circumstances, when you want to run the code multiple times within a range of numbers, then that's when it's used. The for loop, also one of the differences between a for loop and the while loop is that the for loop has a very defined number of iterations. So you go from one initial number to a stopping number. So the range is it's defined at the very beginning. And when that range is finished, it stops repeating that piece of code. Whereas if you're using a while loop, which is based on a true false condition, that could be something that can turn into a it can go into infinity because you're dependent on the condition to be either true or false. Is that true, John?
Yes, that's absolutely right, and it's an excellent point because, and that's the reason that the problem of the infinite loop issue is the reason that we I guess I would say we tend to avoid while loops, or we put a constraint in the while loop that of some maximum number of iterations, because there's no guarantee that the condition on which the while loop is based ever goes false. So we tend to avoid those in Easylanguage. They tend to be a source of bugs, so or problems. So anyway, we can in one of our Easylanguage answer classes, we could talk about sometimes people say, well, look, I'm running a really, really long loop. I don't know how long, but it's going to be long. And, you know, I actually want to avoid the infinite loop detection. And we could talk about stuff like that, which is a little more advanced. You know, but anyway, that you're exactly right, though, on the basic difference.
Yeah. Okay. Here's an example.
Right.
I'm sorry. Yes.
No, go ahead. Yeah.
Here's an example of what a for loop would look like. And then we'll talk about the while loop and we'll address your question, Jen. As you can see here in this example, we have two variables, counter and largest range. Let me go ahead and set the laser pointer so you know where I'm pointing. Here's counter and largest range. These are two variables that are, of course, initialized to 0, and largest range here equals 0. A loop is created in this way. So you say for counter is, of course, a variable that you have declared. For counter equals 1 to 10, begin. So with the word for, you're automatically initiating a loop in Easylanguage that has a counter from 1 to 10. So the iterations here are very defined. The counter is going to increment from 1 all the way to 10 in increments of 1. In this piece of code, it's looking at largest range. At the very beginning, we know that largest range is 0, but in the loop, we are assigning range of a particular bar in history to largest range. So what this code is trying to find is what is the largest range in the past 10, or in this case, 11 iterations. If we go from 1 to 11, oh, that's 10. If it had gone from 0 to 10, then that's 11, but you can decide, what your counter is going to do. So for counter 1 to 10 begin, it's going to start at 1, and 1 is going to be plugged in here in this parameter look back right here for range. It's going to look at the range of the prior bar, compare that to largest range, and if it is, which technically it is because we're looking at a real range, so that's going to be greater than 0, which is the starting value of the largest range, then it's going to assign that value to largest range. And it's going to repeat this, looking at all the prior bars, starting at, the 1 bar back, 2 bars back, 3 bars back, until it reaches the number 10, which pretty much breaks the loop because that's the final number in your counter. However, when I was looking at this example, I said, well, this is the same thing as using the highest or lowest function with the look back in it, right? Isn't it, John? If you use a highest or lowest function,
yes.
wouldn't this do the same?
And that's what I was going to mention is that, and because as you had mentioned, you say, well, does a person have to write a lot of loops when they're working with Easylanguage? And and sometimes you say, well, I don't really find myself writing a lot of loops, and one of the reasons is that we put the loop inside a function, and what happens is that the user then uses the function. So for example, like you said, highest or lowest or common, or even a moving average, right? So if you're using a moving average, you call the average function, and what does it do? It loops back over the number of bars, the length number of bars, and sums up whatever price it is that you're averaging, and then divides by the length, right? So the loop is in the function, and you don't end up having to put it in your own code. So
does the function use the same for loop?
Yes, it does. Yes.
Okay, interesting. Is there any newer language that replaces this type of syntax?
Well, okay, so let me answer that in 2 ways. The first thing to think about is what we call the FC functions. F as in fast, C as in or calculation. So the FC functions, rather than looping, calculate things like a moving average by walking forward, is the term we use, through the bars. And let's just take average FC as an example. If you call average FC, what it does is on the first bar, it does a loop on the first bar. But then on subsequent bars, it just drops the oldest price, adds the newest price, times 1 over the length of the average, if you will. So it proportionally adds to the prior bar's moving average based on the new price. And it's faster that way because there's no loop. So we have a variety of functions that are the FC version. the biggest thing to keep in mind is if you're going to try to use the FC version, see, there's your loop. Jesus is showing you there on the first bar, and then subsequently you just use the prior value of the function and a fraction of the new price to get the new moving average value. So the FC functions are one kind of, the biggest thing is you need to load additional bars if you're in radar screen, and you're going to use those functions. All right. The second thing is that it gets more to the kind of other piece of this class, which is arrays. And Jesus is quite right that sometimes you don't find yourself writing a lot of loops, and it could be because you're actually not using that many arrays. And because looping is common with arrays, because you need a way to iterate through the whole array, right? To do stuff like calculate an average of the array values and things like that. So there is a newer replacement for an array called a vector. And there are other collection classes, we call them, and we can cover some of the collection classes if we want to in one of our Easy Language Answered sessions too. But anyway, to make a long story short, a vector can hold a wide variety of values, so you don't have to, for example, declare, as you would with an array, the data type of the array of the vector. So in an array declaration, you specify a data type: double, float, int, string, etc. In a vector, you don't have to specify the data type, and you can put anything in there into the vector and then iterate through the vector. Anyway, and you can use the same functions with a vector that you use with actually with prices. So anyway, this is a long story, but
yeah, it gets a little bit complicated. I mean, you can take it as
yeah. So we can take that up, but I would say that definitely arrays are still used, and loops, although sometimes, again, as we said, there's the loop's sort of hidden from view in the sense that it's encapsulated by a function.
Yeah, and you can see the two different functions instead of Easy Language. You can just open up the average function, which uses a separate function. It uses the summation function, and the summation function is the one that has the for loop.
The one that does the loop. Yes,
exactly. It does the loop just to add the prices. So this is just adding all the prices together, and the average function is taking that summation total, dividing it by the length, which gives you the average, simple average.
Exactly.
Pretty.
And so there's two functions that have wrapped the loop, right? So it's doubly kind of out of view in the sense that even if you looked at the average function, you wouldn't see a loop. You have to look at summation to finally see the loop.
Exactly. And the FC, or the fast calculation that John was referencing, is right here, which uses the same loop when current bar equals 1. Current bar meaning when it starts off the calculation, the very first bar of the historical period. Is that what it means? Current bar equals 1?
Correct. That's right. Exactly right.
So it does one thing when it calculates on the first bar, and this is where it gets a little bit faster by applying this other formula, right?
Exactly. The sum, you see, is the sum of a bar ago plus the new price minus the oldest, if you will. You know, if it's a 20 bar, then it's the price 19 bars ago. So it does the sum much faster, and that way, by simply adding the new price and dropping the oldest one to keep the moving window, if you will, of the summation, rather than looping back and adding them up all again. And so you say, well, I mean, yeah, that'll save you a little bit, but I mean, is it really that significant? And the answer is that the significance comes into play when you're doing tick by tick updating on a lot of symbols. So you say, well, look, I am updating my moving average tick by tick, and I do have it applied to, I don't know, 500 symbols in radar screen, then that's where you get a little more of the effect, a little performance improvement.
Interesting. Jim has a question. If he gets stuck in a while loop, what happens to the trade session platform? Does the other chart still calculate?
Excellent question. Okay, this gets just a little complex, but I'm gonna dive into it.
Okay.
All right.
Thanks for the warning.
Yes. Heads up, we're going to the deep end of the pool. Okay. Let me just blurt something out, which is Easylanguage is single threaded. Okay, and everybody's going, okay, now what are you trying to tell me here? And what this really means is that if something in Easylanguage kind of gets stuck, if you will, like by a while loop that's not ending, it will hold up all of Easylanguage. And that's the reason that it ultimately can result in a problem, either a runtime error of an infinite loop detection, or it'll ultimately you could crash. The way we prevent crashing is through infinite loop detection. So there's a little more complexity to it, which is that it'll hold up Easylanguage calculation within a process, a given process. So you say, well, okay, what are you talking about? Okay. So if you have radar screen running Easylanguage and a chart running Easylanguage, you're going to have two different processes running, and those will separately calculate. But you might have multiple charts all within the same, we call it OR chart.exe process.
Mm-hmm.
And if they're all in the same process, they're going to all be held up by a stuck while loop. And again, this is the reason that we tend to avoid while loops. One of the reasons. Yeah. Or as I say, we put a condition and we just say, look, if the while loop runs, I don't know, 20,000 iterations, that's it. I'm going to decide on a value and exit the loop.
Yeah. Pretty cool. So similar to
Right.
what I think I have an example here on this PowerPoint that has, let's see if I find it. Yeah, wow,
So
right here.
Just to summarize the answer to Jim's question, will the other charts still calculate? The answer is it depends on the setting that you have for multi-core charting. If you have multi-core charting enabled and the charts are in separate processes, the other charts that are in separate processes will calculate. The charts that are all in the same charting process will stop until the while loop completes.
And okay, so what we don't want is a while loop that gets stuck, right?
Correct.
And if it happens, you're better off just shutting down and restarting your computer to get out of it. Is that the only way, or you just shut down the platform?
Well,
and stop the loop.
Unless you override infinite loop detection, we'll detect and stop it for you. We're going to say, after it runs for a certain period, we're going to say, look, this looks like an infinite loop, and we're going to throw a runtime error and gracefully exit.
Okay.
And you'll get the infinite loop detected error. If you override that, which we could talk about how to override it in one of our Easylanguage answered classes, but if you override the infinite loop detection, then eventually you'll probably run out of memory, and that'll cause a problem.
So what I see here in this example, for example, this goes into the while loop right here, but this line of text, if
there you
look back
go,
equals 10,
that's
then
it.
break.
That's
what gets you out of the loop, right?
If you end up wanting to run a while loop, this is a good practice, is at some point short circuit the loop, and just go ahead and get out of it. If you say, look, I've done what I can't find it, and it's sort of like your own infinite loop detection in a way, where this one's shorter than infinite, but at some point you get out of it.
Right. And it would be sooner than waiting for the system to auto detect that you're
much sooner. That's going to be much sooner, right?
Yeah. So maybe, yeah, good programming practice to put in a break inside of your while condition just to make sure that you can get out of it if this condition never becomes true. Okay, because this loop right here is happening while the condition is false. So you would need a true return in order to break out of it, or hit the number 10 here on the look back. The setting for multi-core processes, that's going to be file preferences network
Desktop.
or desktop. Desktop, that's where the processes settings is.
Correct.
Yeah.
And you can either set it to auto detect. I'm going to that menu right now just so I can make sure I
Let me see. So file preferences desktop. And we
desktop.
go here to performance, or let's see.
Yeah, performance.
Performance right here.
And you can either set it to auto configured or custom or compatibility. Compatibility means one process. So that's the old way we did it. Then there's the auto configured, which looks at your number of cores and makes a decision. And then there's a custom, which is where the max you can do is the number of cores on your CPU, or you can use fewer.
So we don't have one here for Easylanguage. Should we imply that trading app is Easylanguage and strategy optimization runs on Easylanguage, but we don't have any dedicated Easylanguage options here.
No, okay, so Easylanguage requires a host. So what we're really doing here is we're saying how many cores do you want the host to use? And that host, and actually this only applies to charting currently. So in a sense, it's Easylanguage in the sense that the thing that's going to execute the Easylanguage is what you're controlling. In other words, you're saying, look, you let 4 hosts for, or 8 or 12 or however many you decide on. So there's really not a setting per se for Easylanguage, but it's the thing that hosts it. Easylanguage.
Okay, cool. And radar screen, of course, is the host of Easylanguage, but it doesn't apply to radar screen.
No, radar screen is automatically multi-core. So yeah, it's going to use, you could think of it as using the auto configured option, but we do that automatically with radar screen when you create a new window, not a page within a window, but a new window. A new radar screen window, we launch a new instance of OR quote, TS quote. I'm sorry, it's called TS quote.exe.
So here's the array definition, which is also on that PDF that I shared with everyone. An array, I like the example that it's used here when it makes us think about a column in Excel with different values in it that can be referenced using the row number. Now, I have a question for you, John, from a programming perspective. How is this different than a declared variable? A declared variable also is going to store or have a database of historical values that can be referenced by the lookback parameter, right?
Correct.
So how is this different?
This is like declaring 5 variables, or in this case, I guess 6, all at once.
Right here?
Yeah. So you've actually created 6 variables. So you've got my array 0 through my array 5.
Okay.
And so there are cases in which, like, let's say you wanted to store daily values in your array. If you were going to do it with separate variables and you wanted 6 of them, you'd have to declare 6 variables, and you can see the problem already. What if you needed 60? not 6. You'd have to declare 60 variables, one for each prior day, right? In order to, for example, store daily values on an intraday chart. Instead of having to declare all those, you can declare them all kind of at once, if you will, by creating an array. And now you have all 60 variables, if you will, 0 through 59,
Okay.
of your array automatically available to you. And you're right, there's a sense in which, and again, this starts getting more and more complex, but there's a sense in which historical values of variables are themselves an array. So I think and that's what you're kind of mentioning, is that, hey, if I have just a variable and I want to back reference it 5 bars ago, isn't that kind of just like, we're using even the same notation as brackets? Isn't that just looking into, yes, it is, under the covers, it's just looking into an array. So you're right. I mean, there's a little kind of crossover or something here with in the sense that our notation of historical values of prices and variables is very similar to the notation of an array.
Interesting.
And,
so yeah, Jim is making a point here that it's just easier to look at separate variables when you use an array, since you can have, well, I'm not sure what the maximum number of variables you can declare this way, but
I can't remember what the max array size is. I think it's quite large. I'm not even sure that we have a max. It might be limited by your available memory, or there may, I've done arrays in the hundreds of thousands of values and have not hit any limits. I haven't tested the max though.
Okay. This is interesting. This code right here, which seems simple, it has a loop. So for counter 0 to average length minus 1, which in this case would be 0 to 4, begin. And there's my array equals close. Okay, so it's just plugging in values to your array, right? Closing prices to your array.
Correct. So here is this example almost could be used to illustrate the parallel nature of our brackets notation as a look back versus brackets notation as an array index. And those are sort of parallel things. And here we're making that real explicit by saying, I'm going to assign close counter bars ago to my array sub counter. And so I'm basically just duplicating the array of closes. And I'm just going to duplicate that and then sum it up. And this kind of makes it very explicit, the parallel nature of a price array, if you will, and an array that you could create which would contain the same prices.
Yeah, pretty cool. All right, that's great. So and as I always tell somebody that's getting started with programming, it's not until you know for a fact that you need an array that you're going to need an array, right? These are things that are not simple programming, but in certain situations, you're going to feel like, oh, I think I need an array for this to be able to collect historical values. But as John pointed out, now we have a vector, which is a vector easier than an array? What is your impression on that, John?
Well, okay, yeah, that's I would say for numeric values, I find arrays just easier to use, where you get into a little bit of a where vectors become a little easier to use is if you're going to store objects and want to have an array of objects. So if you're doing that, then for example, a vector of vectors, then that sort of construction you would only do with a vector. So you wouldn't have an array. You can't. We don't have a concept of an array of arrays. So but we do have a vector of vectors, or vector of vectors of vectors, or this type of thing. So anyway, that I would say arrays are kind of, as a rule of thumb, easy to use, very easy to use for numeric and even string values.
So vectors just add a little bit more, not complexity, but you can take it and make it more complex if you ever need to.
Yes,
Okay.
exactly. Or that's right. Or, if you needed to store, and again, this starts getting more and more complicated, but a variety of things, the data type of which you don't know in advance. So if for example, you say, well, on this bar, actually, I want to store a string in the quote unquote array. And on the next bar, actually, I need to store a double. And on the next bar, I need to store a Boolean. Well, you could store all those things in one vector. You would have to have separate arrays, because the arrays are by data type.
Interesting.
So anyway, that's the kind of flexibility.
All right. That's it. So that's our class. So we wanted to give you a little bit of information on loops and arrays, and hopefully this clarifies a lot of questions if you had any. And if anybody has any questions, this is your time to do it. But I think we've reached the limit of our class. So John, I want to appreciate your time again.
Oh, you're welcome. My pleasure.
I hope that you have a wonderful remaining Thursday, and I look forward to talking to you next time. Okay.
Sounds good. Take care, guys.
All right, everyone. Talk to you later. Bye-bye.